Hi everyone. Today we'll be discussing the LeetCode problem of the day, taking maximum energy from the Mystic Dungeon. In this problem, you are given a Mystic Dungeon which has n magicians standing in a line. So we have n equal to 9 here. And each magician has an attribute that gives you energy. So some magicians can give you negative energy. That means taking the energy from you. So you have been cursed in such a way that after absorbing energy from magician I, you will be instantly transported to magician I plus k, and this process repeats until uh, there's no magician exist at I plus k. Suppose if you are at here, after absorbing the energy from this magician, you'll instantly be transported to I plus, let's say k equal to 3. So from here you'll be transported to this point, and after absorbing from this magician you'll be transported to I plus k, so you'll be transported here. And after this you'll be transported, there's no magician at I plus k, the process stops. In other words, you can choose any starting point, and from there you will keep teleporting k jumps forward, and in that sequence you'll absorb all the energy in the process. So here you'll absorb the energy of magician 2, 5 and 8, and you stop when there's no magician uh, after at the last jump. And you are given an integer array energy and an integer k, and you just have to return the maximum possible energy you can gain. And in the note it's given that when you reach a magician, you must take the energy from him, whether it's negative or positive. Yeah, so if we start from 2, this is the energy we take. So like in the question, you can choose any starting point. So you can even choose to start at magician 7 directly. So when you start here, you will take the energy at this from this magician, and you will try to go to the next, you'll jump k steps, but there's no magician, so the process stops. So when you start at 7, you only take the energy from the magician 7. So let's see the first example. We have 5, 2, minus 10, minus 5, and then 1. Let me write the index also. And we have k equal to 3. So if you start at index 0, so first you will have 5 magic, and after that you will go k steps. So 1, 2, 3. You will have minus 5 magic. After that you'll go out of bound. So total you'll have 0 energy. And if you start at 1, so first you'll get 2 magic, 2 energy, then you'll go 3 steps, so you'll reach magician 4, which will give you 1 energy, so total 3. And if you start at 2, you'll have minus 10, and after that you'll go out of bound, so you stop. And if you start at index 3, you'll just have minus 5, and at index 4 you'll just have 1. So out of all these, 3 is the maximum, so we just return 3. And if we quickly see the second input, minus 2, minus 3, minus 1, and here we have k equal to 2. You start at index 0, so you will first get minus 2, and then 2 jumps, so minus 1. So total minus 3. And if you start at index 1, then you will start with minus 3, and then after 2 jumps you'll go out of bounds, so you stop there, so the value is minus 3. And if you start at index 2, you'll start with minus 1, and then the process stops. So out of all these, the maximum is minus 1, so you return minus 1. Let's go over the approach. So you just need to find the maximum answer when you consider all the starting points. So let's say we are starting at index 0. So from index 0, okay, you're starting at index 0, and let's say k equal to 3. So from 0, you'll move k steps. So you'll go to index 3, and then again k steps, you'll go to index 6, and then you stop. So when you start at 0, this is the energy you'll take from magician 0, magician 3, and 6. And you start at index 1, then you'll go to index 4, then you'll go to index 7, and then you stop. And finally, you start at index 2, you will go to index 5 next, and you'll go to index 8, and then you stop. So now we have checked for uh, by starting at index 0, starting at index 1, and starting at index 2. Now if you see that if you start at index 3, you're repeating the same path as you started from index 0. So when you start at index 0, you're moving from 0 to 3 to 6. So if you start at index 3, so you'll repeat the same thing. You'll start at 3 and you'll end up at 6. And similarly, if you start at 6, you end at 6. So it's also in the same path. So to avoid the duplicate calculations, what we can do is, uh, once we have this chain, if you start from 0 and you go to 3 and you go to 6, so what we can do is, once we have this path, we can first calculate the answer for 6, and then add the value of the 3. So you will have answer for 3 plus 6, answer for 3 and 6. And after this 3, also add the value of 2. So then you will have the answer for 0, 3, and 6. So in this chain, you are kind of doing a suffix sum array. So first you will get the answer for 6. Then here you will have 6 plus 3, and here you will have 0 plus 6 plus 3. So by doing this, you have covered all these starting points. So this is the answer when you start at 6. This is the answer when you start at 3. And this is the answer when you start at 0. So this process you need to repeat it k times, because if you see, the next chain is 1, 4, and 7. So out of this, again, you started iterating from behind. So first calculate the answer for 7, and then to this answer add 4. So that will give you the answer for when you start at 4 and 7. And to this answer add the energy of 1. So that will give you the answer when you have started with 1. So by doing this, you calculate the answer for all these starting points. And similarly, you repeat the process for 2. So this 2 chain is 2, 5, and 8. So same thing, you calculate the answer for 8, and then to that answer add the energy of 5. So that will give you the answer when you start at 8. And to that value you add 2, energy of 2. So that will give you the answer when you have started at 2. So 2, 5, and 8. So by doing this, again, we have covered all the starting points. So if you see, if you just do it k times, you have covered all the starting points. So out of all these values, you can just return the maximum value. So when you want to code this approach, what you can do is, since we want the suffix sums, we can just start iterating from the right side. So let me quickly erase this part. Yeah. So first you'll start it here, and then In your answer, you will store the energy of 8, and then you will move k steps. So from 8, you'll go to 5. So you will add this energy also, and that will give you the answer of 5 comma 8. So from 8, you will jump to 5, and from 5, you will jump to 2. So this sum will give you the answer of 2 comma 5 comma 8. So when you start at 8, this is the process you take, and you need to again start at 7. Also, you need to start at 6, and then you need to stop, because uh, you don't need to start at 5 again, because when you start at 8 only in this chain, you have calculated the answer for starting at 5. So you just need to iterate on the last k elements. You need to start the starting point at the last k elements, and keep iterating on the loop. So I'll just take an example. I'll just use the first example for this approach. Minus 10, minus 5, and then 1. And let me just write the index 0, 1, 2, 3, 4. So here k value equal to 3. So first you'll start at 4. So in your sum, you will have the value as 1. And in your answer also, you have the value as 1. So when you started here, you have the sum as 1. That means you have covered the case where you will be starting at 4. So if you start at 4, your answer will be only 1. So after this, you will go k steps, and you will add this value in your sum. 1 plus 2, which is 3. So currently you have the sum as 3. So sum is greater than answer. So you will update the answer as 3. That means you have found a bigger answer. So what this sum 3 represents? It represents the answer when you start at index 1. So if you start at index 1, what happens? First you add 2, then you move k steps and you add 1. So at the end of the day, you will get the 3 again. So by doing this, you have calculated the answer when you started at index 4 and also at index 1. And after this, you'll again try to move k steps, and it goes out of bounds, so you stop. So 4 is done. Now you'll start from 3. We take a different color. Now you'll start at 3. Again, the same thing. So sum will be reset. So first sum will have minus 5. Now you'll check if minus 5 is greater than answer. It's not, so you don't update it. And this minus 5 is the answer when you start at index 3. So starting at index 3 case is also covered. And from here, you'll move k steps behind. So you'll reach at index 0. So you'll add 5, and you have the sum as 0. Sum. And 0 is not greater than 3, so you won't update it. And this sum 0, you will get it when you start at index 0. So if you see when you start at index 0, so first you'll have 5, and then you'll move k steps, and you'll add minus 5, and the answer is 0. So that means basically you have covered the case where you have started at index 0 also. And then you'll go k steps behind, and it's out of bounds, so you stop. So finally, you'll start at this index 2. So and again, sum will be reset. Sum will be minus 20. This is minus 10, I guess. Yeah. Sum is minus 10. And minus 10 is not greater than answer. So answer remains 3. And this minus 10 denotes that it denotes the case where you start at index 2. So this case is also covered. And then you'll try to move k steps behind. There's no element left. So you stop. So if you see, you repeat the process only k times. So k equal to 3. So you started the loop for this, and for this, and for this. So by doing only k times, you have covered the starting point of the whole array. So at the end, whatever is the answer, you'll just return that. Now let's quickly code the approach. Let me take the size of the array. So we are iterating from behind, and we need to iterate only the last k elements. So int I equal to n minus 1 from the last, and I is greater than equal to n minus k and I minus minus. So from here, we need to start the loop by the starting point is I, and we keep moving k steps behind. So let's take a sum variable 0. So the second loop is used to iterate k steps to the left until j is negative. So we have energy of j, and then we compare it with answer. So we also need to take an answer variable. Initially, let's say integer dot min value. Then once we have the sum, let's just compare it with answer. Answer comma sum, and at the end just return answer. Okay, n equal to integer length, answer is integer minimum value. Okay, in this loop you have to jump k steps, not one step. So j starting from I, and j greater than or equal to 0, and j equal to j minus k, since you want to jump k steps behind. Yeah, let me submit. It works. Finally, let's go over the time and space complexity analysis. So for the time complexity, we have the first loop, which is running k times, and inside the loop, it looks like this is also running n by k times. But if we see that we don't iterate on the same element twice. So in these both loops, all the elements are visited only once. So the total complexity will be order of n only. And if we go to the space complexity, it will be order of 1, since we are using since we are not using any arrays. And I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.